morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Lubinda with another video. Additional mathematics, vectors. This video is on answering questions using the I and J component form. Alright, question reads, the position vectors A, B, and C are 2i minus j, 3i plus 2j, and negative 3i plus 4j respectively. Show that triangle ABC is right angled. First of all, we start by writing the position vectors, which is OA is equal to 2i minus j, OB is equal to 3i plus 2j, and then we have the third one, OC is equal to minus 3i plus 4j, like that. So they want us to show that ABC is right angled. It's a right angled triangle. First of all, you need to play around with these three vectors. It means we have the letters A, B, and C. So you need to use the letters A, B, and C, not the position vectors. What I mean is that you need to find something we call resultant vector. Resultant vector comes about as a result of adding two vectors, two or more vectors. That is a resultant vector. So for example, we can have a resultant vector like AB, then we can have a resultant vector like AC, and then BC. So these are the three resultant vectors that when you have right angle triangle, alright, we don't know which one will be C, we don't know which one will be A and B, because these are adjacent sides and this is the hypotenuse. So we need to prove that these three vectors right here, they form a right angle triangle. So it's about answering and knowing our resultant vectors. Okay, so this means we'll have AB is equal to AO plus OB. AO is minus 2i plus j. OB is 3i plus 2j, which is equal to minus 2i plus 3j, minus 2i plus 3i, sorry, plus j plus 2j. This will give you a positive I plus 3j. So it means that our AB is equal to I plus 3j. Alright, after we find it like that, we now go to the next one, which is our AC. So AC is equal to AO plus OC. AO is minus 2i plus j, then OC is as we can see here, OC we just get it as it is, minus 3i plus 4j. This will be equal to minus 2i, then minus 3i plus j plus 4j. This will be equal to minus 5i plus 5j. And this is our AC. So AC is equal to minus 5i plus 5j. Alright, after finding our AC, then we also find our BC. So BC is equal to BO plus OC. BO means we're going in the opposite direction of OB, which means everything that is positive becomes negative. BO therefore will be minus 3i minus 2j minus 3i plus 4j, like that. Which means we're just getting this as it is. This will be equal to minus 3i minus 3i minus 2j plus 4j. This is minus 6i plus 2j as our BC. Alright, So that is our OC like that, then our BO is like that. So BC is equal to minus 6I plus 2J. These vectors are very important that we have found right here. Then the next step is a right angled triangle follows the Pythagoras theorem. C squared is equal to A squared plus B squared, which is a right angled triangle like that. This is alright. So you have your right angled triangle like that. This is your C, this is your A, this is your B as adjacent sides. Then you have these three vectors right there. How do we prove that it is right angled? So I'm going to use the magnitude. Let's find the magnitude of AB. So we're going to say AB like that with 2 bars is equal to square root of the x component 1 squared plus 3 squared, which is equal to square root of 1 plus 9 square root of 10 is our A, is the magnitude of AB. Then we'll also look for the magnitude of AC, which is equal to square root of negative 5 squared plus 5 positive 5 squared because of the 5j. It will be equal to square root of 25 plus 25. Therefore our AC is equal to square root of 50. So that's our AC like that. And then we have our BC. BC is equal to the magnitude of BC like that, square root of x component negative 6 squared, then plus 2 squared. This will give you square root of 36 plus 4. This will give you square root of 40. And that is our BC. The magnitude of BC is equal to square root of 40. So magnitude of AB, square root of 10, magnitude of AC, 50, the magnitude of BC is 40. Alright, so we can now just write that information right here. So AB is square root of 10, AC is square root of 50, and then BC is square root of 40. Okay, square root of 40. And then we can then put these 2 bars to represent the magnitude of these vectors. So it means we have almost answered the question. So if you look at these right here, we can use the Pythagoras theorem to prove. So C squared is equal to A squared plus B squared. This means that we are saying C squared. The biggest that we can see here is square root of 50. So we'll just get square root of 50 as it is squared is equal to A squared, which is square root of 10, which has to be squared. B squared is square root of 40, square root of 40, which also has to be squared. Then if we square root of 50, it means the square symbol will cancel. It means 50 would be equal to, even here the square symbol will cancel 10. Then here it will cancel plus 40. 50 is equal to 50. So upon you proving that 50 is equal to 50, you say, therefore, or let us start saying, because AB, magnitude of AB is equal to square root of 10, magnitude of AC. So this symbol, the upside down, therefore, means because. So because magnitude of AB is equal to square root of 10, then magnitude of AC is equal to square root of 50, right there, and magnitude of BC is equal to square root of 40. Triangle ABC is right angled. And that would be your final answer. Thank you so much for watching this video. This has been Cornelius Zubinda with another video, and bye bye.